Thank you. Well, the organization of this stage is very clear. Hans is the physics guy, and you're the NLP guy, and I'm the cognitive science guy. We're the three invited speakers. I'm not an NLP person. I don't know very much of what's going on here, but I hope to say some things that are relevant to the NLP community here. One small warning is that I will talk about vectors and vector spaces, but I use them in a different way from what they are used in NLP, so you should be aware of that. Dominique wrote a book it's called Geometry and Meaning. I wrote a book called Geometry of Meaning. So I'll take up a couple of themes from that book. Part of that book contains cognitive semantics of word classes based on conceptual spaces. I'll give a summary of that theory. And then hopefully I will say something about implications for the NLP. But I have done a few things since this book came out a couple of years ago. So there are some new stuff in my presentation that you won't find in the book. But basically, I will try to answer this question. Not answer, but I'm trying to give a semantic theory of word classes. And if you look at linguistics, word classes are defined by syntax. And you have syntactic roles, I think, and so on. But when you learn word classes in primary school, you learn that nouns are about things, adjectives are about properties, verbs are about actions, and so on. That's how you learn the word classes. And that's how I want to model it. I want to give a semantic definition of word classes. Forget about the syntax. I want to give a totally syntax-free definition of word classes. That's what I'm after. Okay, so that's the goal. And another assumption in this kind of more formal work is that each occurrence of a word, when you find in the corpus and or linguistics, is supposed to belong to a particular word class. And then you have very good counter-examples, like round. That can be used as noun, verb, adjective, and so on. And when you do the analysis, when you do your parsing in a text, you end up sorting up round as one of those. But what you miss is that there is something common to the meaning of round in all these uses. And that's not captured in the theories. There is something that is common to the semantics, even if this word ends up as a totally different word class. Well, we had the example of cut earlier today. That can be a noun, and adjective, and a verb. So that's another example here. So that's a problem. We want to keep say something about what is common to the meanings of the word. I mean, we talked about polysemy. I mean, this is converse of polysemy. This is the word having some meaning, but still being different grammatical categories. So that's what is my aim. I wrote the previous book, and I start with this, Conceptual Spaces. And a conceptual space, I will give a very brief summary. A number of dimensions, examples here are color, size, shape, speed, weight, position, force, temperature, things. And these dimensions come with some topological geometrical structures. I'll give you an example in a minute. What's important here for me is that these dimensions are sorted into domains. There is a space domain, there is a color domain, and okay, many of these, like weight, is only one dimension. Temperature is one dimension, but shape has many dimensions. Maybe not size. Okay, so they sorted into domains. So my favorite example is the this is my favorite idea, that I sort concepts as convex regions of conceptual spaces. And I really build on that idea now here, that convexity is a very general cognitive principle for how we organize things. And that's why I call my model a geometrical model. And I live on this convexity idea. So here is one example of a domain. This is a psychological representation of how humans perceive colors. We have a three-dimensional color space. Other animals have two-dimensional or four-dimensional, but we happen to have a three-dimensional space. And there is the color circle, the hue. There is the intensity. I should have written gray in the middle here. And there is the brightness. These three dimensions are not independent. As you get closer to the white, you can make fewer discriminations. these spaces are based on how we discriminate colors in our perceptual fields. And you can do it by multidimensional scaling or whatever. And the meaning of a color word, like red in English, is a region of the color space. I can't really draw three-dimensional pictures here, but the idea of a convexity is that something is called red and something else is called red, and anything in between is called red. That's the convexity idea. I put forward this idea when I published this book in year 2000. 10 years later, Gerhard Jäger in Tübingen, a linguist, went through 110 languages. Different languages have different color terminology. But he found very strong support for this idea. All color terminology in all languages represent convex regions. So that seems to be a universal principle. So, what is a domain? Well, in linguistics, people like Lanaker talk about both dimensional and meronomic structures. So he says that the domain of a thumb is the hand, the domain of the hand is the arm, the domain of the arm is the body. So he uses domain in that terminology. I don't like that. I call that meronomy, and that's something else. I will only discuss domains in terms of dimensional structures. I mean, for those of you who have a background in cognitive linguistics, this is a bit of a different what goes on, and I've written an article about this kind of dimension. A fundamental distinction for me is between properties and object categories. And for me, if you do predicate logic, everything is a predicate. I mean, red is a predicate, horse is a predicate, run is a predicate. So all word classes, all content word classes are bundled together into predicates and predicate logic. I don't like that. So I make a distinction, but first of all, between properties and categories. And a property for me is a convex region in a single domain. So, and I gave you the example of red. That is a property. And here is the first semantic principle. It's a fairly strong, but maybe lots of counterexamples, but I still put it forward. The meaning of adjective is described as a convex region in a single domain. So that's a general semantic recipe for what an adjective means. So the adjective heavy relates to the weight domain, the adjective hot relates to the temperature domain, bitter to the taste domain. Taste, we have 4 or 5 dimensions depending on how you count. And round relates to the shape domain. The basic meaning of round is a shape. Well, round is an adjective. And the convexity requirement entails that there are no words in natural languages that mean things like green or orange, because these are non-connected and definitely non-convex regions of a domain. And the single domain idea means that there are no adjectives that mean long and hot, because they are co-connecting 2 domains. I don't know. I mean, I haven't run a very detailed empirical study on the meaning of all adjectives. I'm putting this forward as a fairly bold hypothesis on how we are assigning meanings. And my reason for doing this is that I think that when children learn languages, they go by heuristics like this. When they pick up the meaning of a new word, the adjective will be marked as an adjective in the grammar. They know it's an adjective, then they know they have to look for some meaning in some domain, in a single domain. So this will help. If this principle, this single domain constraint is valid, it will help them pick up the meanings of new words. It will speed up the language learning. That's my main motivation for saying, I mean, this is maybe not a universally valid principle, but it's a heuristics that you can use when you learn a new language, or when you learn your first language in particular. Second type is what I call object categories. So this is the semantic foundation for nouns. So if you talk about a dog has a lot of properties. It has a size, it has a shape, it has a sound, it has a smell, it has a weight, it has a temperature, has lots of properties. And dogs have more or less, I mean, some of the properties are more important. I mean, the shape of a dog and maybe the smell and the sound of a dog is more important than its temperature and so when we are learning about dogs. But anyway, my idea is that a noun is categorized by a number of convex regions in different domains. And then some of them are more important, and we also learn information about how the domains are correlated. So let me give you a toy example here, meaning of apple. So when we are kids, we learn that apples are red, green, yellow. That's the region of the space. They have taste has sweetness, sourness, bitterness, and saltiness. And for apples, bitter and salty are maybe not so important. It's mainly sweet and sour that comes in here. Shape is basically, well, not round, but something similar to round of shape space. We know how apples are shaped. Main distinction between apples and pears is the shape of them. Nutrition, we can start talking and so on. There might be, we don't care about where the apple is located, so there is no constraint on the space. Even if the apple has a space location, we don't really care about that. When we are kids, we learn about apple by these three domains, and then maybe when we grow up, we learn more. We can add new domains to the meaning of a noun. So the meaning of a concept, of a noun, is not fixed. It can be dynamic. I'm not buying anything like necessary and sufficient conditions for the meaning of a noun here. So, and the correlation here. I mean, sweetness is correlated with color for many fruits, for instance. The sound of a dog is correlated with its size, and so on. We learn about these correlations. Okay, I want to give you an example here. So this is the second thesis here. Concrete nouns. I mean, these are physical objects. Refer to what I call object categories here. We have other types of nouns, and I'll get back to them in a few minutes. No, actually, I will get back to them right now. And that is, now I make a complaint here. We've been taught in linguistics, all the day we've been talking about nouns and verbs and adjectives and so on. And that's a classification, linguistic classification, that applies well to Indo-European languages, but doesn't apply to languages in general. And the reason we have this is that the first grammarians did Sanskrit, and the next grammarians did Latin. And then we borrowed all these linguistic categories, I mean, that we are talking about now, noun and adjective and verb and so on, from these grammarians. But they are Indo-European languages. There are lots of languages where these categories don't fit at all. And I'll give you one example of this by sorting up nouns. So we can distinguish between different kinds of nouns. So we can have nouns that talks about places like the sea or the forest or things like that. And they are very often, they depend on the space domain. They have a location. When I talk about an apple, it doesn't depend on the space domain. I mean, we can talk about the space of an apple, but an apple is not defined in terms of its space. But places are defined in terms of, so for places, the space domain is the most important one. Mass nouns, like water, like gold, and so on, we don't care about the shape. I mean, we talk about mass nouns don't contain information about shape. But concrete objects like dogs and chairs and apples, they have shapes. So what is the distinction between mass nouns and count nouns is that the shape domain is not important here. That's my analysis. I mean, that doesn't fit with the analysis of most linguistics, but that's my way of doing it. Concrete nouns, they have these object category domains. I mean, they have sizes and shapes and weights and so on, all these object properties. And that's a lot of domains. I mean, that's our biggest class of nouns are these concrete, and we have lots of domains for them. And it's an open-ended set of domains. We can learn about new properties of objects and so on. We have abstract nouns. What characterizes them is that they forbid a location in the space. That's totally excluded. I mean, a concrete noun has a location, but it's not important for its meaning. will talk about the force domain in a while. But an agent is somebody who can act. And acting means exerting a force. You can have mental actions as well, but that's a metaphorical extension. So agents is a particular type of nouns that have accessible, can use the force domain. So I'm bringing in different, and then you have intentional agents that have goals. And you have a goal domain, and I don't want to talk about that. Now, these are some types of nouns. And in the European languages, they are nouns. They're bundled together in one category called nouns. In lots of other languages, they are separated. You have different grammatical category for the mouse noun and for the different categories. And you can sort them up, and many languages have what is called noun classifiers. You have to add a word to the noun in order to mark what type of noun it is. We don't have to do that in most Indo-European languages. So you can have different syntactic treatments of these kinds. So we bundle, in our type of language, we bundle them together under the rubric of a noun. But that's not obligatory. You can do it. So I make a lot of semantic distinctions here. So here is a toy table. I mean, these are the nouns I have talked about, and here are some domains. I mean, object categories are there is size, space, and size, shape, weight, and so on. Material is what things is made out of. You have shape, you have force, you have emotion, you have goal. There could be other mental here. Double plus means that this property is essential for a particular noun. Plus means that you have it. Question mark means that it can be represented and not represented. Minus means it's forbidden, it doesn't exist. So this is a kind of toy analysis of some of the classes of nouns. Places need the spatial location. That's what defines a place. You can talk about a forest consists of trees. That would be the material. A forest can have a shape, but you can have a sea or an ocean. It doesn't. Well, it has a shape, but that's not so important, and so on. Concrete nouns. These are the main ones. They have object categories. They have a material. They have a shape. That's what categorizes. They have a place. They have a location. But that's not important for the object categories. Some of them can exert forces, not all of them. But object categories don't have emotions, they don't have goals, they don't have mental things. Mass nouns, well, you can have a location maybe. But what's important for a mass noun is the material. That's the central domain for a mass noun. And abstract nouns, they don't have a spatial location, they don't have a size, they don't have a material. You can maybe talk about shape, but they have other domains, and depending on what kind of abstract nouns you get different domains. Agentive, they are people or animals in general, maybe robots, and they have material and shape, but they can exert force. That's the definition here. And intentional, they have a goal space, and goal space is well, I don't want to talk about that. Now, as I said, adjectives. So you can get, you see that I sort up the nouns in different ways here. And you can treat them, I mean, grammar can sort them up in different ways as well. Now I said that adjectives denote regions in domains. So what I've given you down here are some adjectives that are special. So long and deep, they are spatial adjectives. Hot, red, and heavy, they are object categories. Material, watery, golden. Shape, round, pointed, oblong, what have you. Force, strong, weak. Emotion, glad, sad, mad. Yeah, not very many adjectives for the goal domain, but anyway, and I don't know, I don't really find. But anyway, you can find some kind of adjectives for each of these domains. I can now make empirical predictions from this sort of sorting here, because minus means that this adjective will not occur here. So here are the predictions. You will not have round water, because water doesn't have this shape domain. That's nonsense. You won't have happy gold, because this combination doesn't go with material objects. You won't have strong gardens. because gardens don't have the force and so on. So this is an empirical prediction. You will not find these combinations in any corpus.
But you will find them in Alice in Wonderland.
Yes, you will, and you will find them in poetry and so on. There are, of course, metaphorical extensions. There you can have metaphorical uses of things, yes.
Well, there's a coercive use as well, that if I said, I've got a really strong garden at the moment, you would presume that, happy plants, well watered.
Okay, maybe I should weaken my prediction, and I say if you find these combinations, they are metaphorical.
Right.
Yeah. Okay.
That
should be
incredible capacity for coercing meanings, because we presume your meaning.
Sure. We want to add meanings. Any impossible combination, we try to find a meaning, and we have lots of processes for doing it. But I mean, in general, if you take the literal meanings, these combinations don't exist.
Round water exists in space on the ISS.
Okay, that could almost be an example in favour of the theory, because we wouldn't describe it as round water. Like a sea might be a round body of water, but we'd give it a different name to say like it's a round puddle.
Yeah.
Yes, or a spherical droplet, I guess. Yeah.
Okay. One more example: red happiness. I mean, you have. So.
Happiness after murder.
I'm sorry.
Happiness after murder.
This is good. We get all kinds of discussions. Anyway, so my idea is that what you could do, I mean, to get this classification, my matrix, you say that you can know a man by the company he has. You can know a noun by the company it has. So you can see, if you find a new noun you don't you haven't seen before, you want to translate it or something like that. Check what adjectives it combines with, and then you can sort it out in what kind. Is it a vast noun or is it an agentive noun, or what is it? So by looking at the company of adjectives, you can find out what is the category here. So that's something about the role of domains when it comes to the relation between nouns and adjectives. That's all I want to say about nouns and adjectives. I want to spend most of my time on events and verbs. I'll say a few words about prepositions as well, and then I come to some general conclusions. So, events. What is an event? And in semantics, this question has not been treated at all. Very little. I mean, there are some philosophical notions of events, but they don't make much sense in terms of semantics of natural language. So together with Massimo Vaglian, I came up with a model of an event that says that an event consists of two vectors. One force vector acting on the patient, and then something happens to the patient, and that's a result vector. Most of the time there is an agent generating the force vector, but that's not necessary. I'll give you some example. So an event consists of two vectors and one thing. The patient in the middle, that's an event. And since we talked about episodic memory during the lunch, I think that this is what our event memory consists of. A memory of something that forced something to happen. I kicked the ball and the ball rolled. And so this is the event. It's what was the cause and what was the result. Immanuel Kant talked about mental a priori structures, and I think this is part of our a priori mental structure. We have this kind of mental model of an event. So, forcefully, I've already said that. Sometimes, I call it a vector. I mean, if I'm pushing things, it's a vector. But very often it's a complicated thing. It's a pattern. But let's talk about it as a vector. And it's from force space, generated by an action. I have a theory of actions, but I don't want to talk about that here. And the result vector describes the changes of the properties of the patient. Sometimes, of course, there is no property. If I'm saying that the soup, there is no change, I'm saying that the soup is hot, then the change of the temperature, I mean, there is a null verb here, just saying that we have this state. No change means that it is a state. So I take states to be special cases of events where there is when the result vector is the null vector. Yeah, more generally, force pattern and result path. The result can be complicated. So here's a very simple example. Here is the agent, that's the patient, that's the force vector, that's the result vector. Somebody pulling a box up ahead. So it's a very simple example of how this is mapped. When I talk about changes, this is a change either in location. I kicked the ball, and the ball is happening. What's happening to the ball is that it's changing location. Move is a verb describing that. Or I heated the soup. Then the soup changes its temperature. It's a change in that domain, in the temperature domain. So the change vector can be either spatial changes or changes in object properties. That's the result vector. Sometimes the agent, I'm sorry, no, that's not here. Yeah. Sometimes agents is not necessary. Sometimes the force comes from the patient itself, or it comes from gravity. Something falling, there is no agent here. When a tree is growing, the tree is, well, there is forces inside the tree that causes it. So there is no agent necessary. And sometimes the agent is equal to the patient. When I'm walking, I'm exerting a force on myself to move. I mean, all these self-movements, then the agent and the patient are identical. So that's also a special category. And in some languages you have reflexive verbs. And reflexive verbs very often mark this case when the agent and the patient are similar. It's not a perfect mapping, but that's another way of seeing how grammar comes out of this this kind of structure. Now I'm putting forward another very bold idea here about verb meanings. So I do the same thing here as I did for adjectives. Single domain constraint for verbs. The meaning of a verb root, I mean, I don't care about inflections now, is a convex region of vectors that depends only on the single domain. Convexity again, single domain again. Let me give you a couple of examples. Push is a force vector. Belongs to the force domain. And I can push hard, I can push strongly, I can push weakly, but I can anything in between I can also push. So it's a convex set of vectors. Move refers to changes in the spatial domain. I can move the glass from here, I can move the glass from there, it's a change in the spatial domain. I can move it to anything in between. So, I mean, that spaces are very often convex, that's no problem. Heat refers to changes in the temperature. Now, I'm claiming that each single use of a verb refers to single domain. Now we may have a bit of polysemy here as well. We always have these problems, but basically this is what I'm claiming for the semantics of verbs. And if it works, I mean, it's a very considerable reduction of how we should represent or could represent meanings of verbs. So let me spell out the predictions here. So from this it follows that there are no verbs that means walk and burn. I mean, you may find counterexample, but anyway, that would be multiple domains. There are no verbs that means crawl or run. That's in non-convex. There could be verbs that means run or jog, because the run and jog are close as action patterns. And we can make all kinds of distinctions here. So let me get to these predictions here. This theory explains similarities of verb meanings. It explains why running and jogging are more similar as actions than running and crawling are, for instance. Because the force pattern you're exerting when you're running is very similar to the pattern you're doing when you're jogging. And similarity here, I mean, I don't really have a very good psychological theory, but you can ask anybody about what, and people do this, psychologists do these experiments on similarities of actions. So nobody who has worked on verb semantics have had any idea about how we can explain verb similarity. By having force vectors or property vectors, result vectors, we can see distances between the vectors. And then you can talk about similarities. And these similarities show up also when you do subcategories of verbs. So I talked about walking, and we can have all kinds of subcategories here, where you have special force patterns. I mean, marching is a particular pattern where you walk with straight legs and so on. Yeah, I don't know how to describe all these in force dynamic terms, but we recognize them as subregions. They are subspaces of the vector space of all kinds of walks. So we get subcategorizations as subregions of the regions here. This is a funny thing. We can talk. Verbs are more metaphorical than you're aware of. Just start looking. Look at any sports page in any newspaper. I mean, you will find lots of metaphorical uses of verbs. Here's a simple one. You move the meeting to Friday. The meeting is an abstract thing. How can you move the meeting? Well, what's happening is that you make a transfer from moving in space to moving in time. And that transfer to, I mean, the spatial relations in time and space, that kind of metaphor is very common. And now we're using this transfer from space to time to talk about moving a meeting to Friday. This is an example from an experiment. A boy had spilled milk on the table and he sucked it with his mouth. And it's described as vacuum with his mouth. This is a metaphor you never heard about before, I think. But you can immediately understand it. Because when he's sucking, he uses the same kind of force pattern as when you're vacuuming with a vacuum cleaner. So it's the similarity of the force pattern that gives you the meaning of the metaphor here. Or similarly, slice a tennis ball. You normally slice bread or sausages. And this is this kind of movement. And when you're slicing a tennis ball, this is the same kind of movement you're doing. Okay, that's a child experiment, my bottom burn. That's also similar, maybe. Okay, so you get an understanding of metaphors of verbs by looking at the similarities of the force patterns across domains, or across, not across domains, across objects here. And another thing is that linguists, not all, but some claim that verbs can be divided into manner and result verbs. And once you've heard my theory of events here, this is obvious, because the manner verbs, they refer to the force vectors, and the result verbs refer to the result vectors. So that distinction comes out for free in this theory of events. In this theory of verbs, I should say. Some languages make, well, even in English there are some small grammatical distinctions, how you use the verbs, I don't remember. But some languages have large grammatical distinctions between these two classes of verbs. So, you could have, I mean, verbs are bundled together in one category in our languages. But some languages make this distinction between verbs referring to forces and verbs referring to results. They show up in other ways, and I'll give you an example soon. That's what I said, okay. And then you have state verbs. Somebody is sleeping, somebody sleeps. It means that you're in a particular state, it's going on, but there is no change in the result. You have a particular state, and that's the kind of point in, well, I don't know, physiological space, whatever that is. Okay, so that's verbs. Now we get to prepositions. And the typical use of most prepositions are, actually describe result vectors or I shouldn't say result vectors, vectors in the spatial domains. There are prepositions that are not referring to spatial relations. There are temporal prepositions, like before and after. They refer to relations in time. And there are prepositions that relate to the force domain, like against, or even on is relating to the force domain, because on depends on support from below. But that's a side remark. So, when you can make a distinction between, linguists make distinction between two kinds of prepositions. One is locational. You describe the location in relation to an object. And here are some examples of the locational prepositions. And they describe states. That is, they describe points in space, basically. Yeah, points inside an object, near an object, and so on. You have the directional preposition into, towards, out of, through, and across, and around, and so on. They describe events. They're result vectors that have different start and end points. They are real vectors. You can argue that the regions here are convex. These regions are convex, these regions are convex. But in order to do that, you have to do it in terms of polar coordinates instead of Cartesian coordinates. So polar coordinates come in here. That's another story. I don't want to get into the details, but I can give you. So, I should have written. I'm sorry. There is a single domain thesis even for prepositions. A preposition refers to a convex region of a single domain. So I've given you this is a set of points. This is a set of vectors, but they are also convex. So I can do the same thing here. And some have the temporal domain, some have the force domain. But the basic meaning of a preposition depends on one domain. The problem with this is that we have an enormous amount of metaphorical uses of prepositions. We can use prepositions for all kinds of things. So that makes the situation a little bit more complicated.
Can I ask?
Yes?
What about the preposition, like a preposition like for?
Like?
For.
For?
Yeah. It seems totally different to any.
Yeah, yeah. Oh, that's a good one. I think you would have to get into some kind of intentional domain here, the go domain. This is for something. You have. I haven't. I never thought about that example. Okay, I should have. Okay, thank you. My answer off the cuff is that it relates to the go domain. Adverbs is tough because it's kind of, some people define adverbs as the rest of the words, those that are leftovers. But anyway, let me talk a little bit about adverbs that modify verbs. So my question is, can we defend this single domain here, thesis here too? I don't know. I haven't really looked into adverbs, but there are some cases. I mean, like I speak slowly. What happens here is that speaking is a manner verb. I'm doing something with my mouth. Some sounds come out, but this process, this action, it can be done in different temporal perspectives. I can do it slowly. I can do it quickly. So you're modifying the force vectors, or the force pattern in this case. Speak loudly. Now I'm modifying another aspect. I'm modifying the volume of my action, or the sound. I mean the effort I do here. Or you can push the door softly. You're modifying the force domain here. Well, these are actually also modifying. Well, you're modifying it, but the result slowly comes out as part of the result here. Yeah. But anyway, what I'm trying to say that these adverbs function as multipliers on these vectors. You can multiply them in different. You can multiply their size, their strength, and so on. That's not the full analysis of adverbs. I don't think we can give it, because adverbs is a very complicated word class, and I think it's just an artifact. I mean, these are basically leftover. But you can find some patterns, like many adverbs function as multipliers on vectors or on other things. So, here is a summary. Object categories correspond to nouns, properties correspond to adjectives, spatial and force and temporal and maybe goal relations is the meaning of prepositions. Verbs refer to force and result vectors, adverbs to modifying vectors. And next. And I'll say in a minute I'll say why sentences refer to events. That's the top category here. Before that I'll say that I've put forward this idea of single domain reference for convex regions for these 4 word classes. And again, the cognitive reason for this is it's a kind of economy principle that if languages were perfectly like that, it would improve our ability to learn the languages. So I don't really care if there are counterexamples to these theses. It's good enough that most of the words that kids learn first follow these principles. That's enough for them to, because once you have a grammar, you can construct new words, you can make new combinations and so on. But you have to somehow ground the meanings of the words before you can do these complicated things. And these principles would help you in the grounding. Okay, let me say something about how I interpret the meaning of sentences. So now I'm focusing on declarative sentences. They expect a construal, and a construal is a notion that linguists use to say that when we talk about the world, we don't talk about everything we see or perceive. We make a selection, and that's a mental selection, and that selection is the construal of an event. But my hypothesis here is that any construal that we make involves something that is the patient or maybe the agent. I mean, it's one of these roads here, and it involves one of these vectors. So a minimal construal an event has one object, either the patient or the agent, and one vector, either the result or the force vector. And this is a bit of a roundabout way, but you get automatically the distinction between the noun phrase and the verb phrase, because the noun phrase refers to the object, the agent or the patient, and the verb phrase refers to the force or the result vector. So if, you can say I've constructed this in order to have this, but that's not the only reason. There are other reasons as well. So in analogy with the visual process, the sentence focuses on some parts of an event. So we have ordinary sentence like Susan hits Oscar, where this is the agent and that's the patient. Now agent maps onto the subject and patient maps onto the object of the sentence. Here it's the other way around. Oscar was hit by Susan. Now the subject of the sentence is the patient, and the agent is the object of the sentence here. So there is no real simple mapping between agent, patient, and subject object in I think this holds for Indo-European languages. There are other languages, ergative and so on, where this mapping is more constrained. But in the European languages, it's the focus that determines the subject. What you're focusing on, and the subject is the focus of your construal. That's the idea here. Woof. So that's the semantic theory. Now I'll get to the last 2 minutes to connections to NLP here. So I have presented to you some kind of semantic ontology of word classes. Adjectives are regions of a domain. Nouns are products of regions, and now I really mean product in the sense of products of spaces, maybe together with information of correlations between in these products. Prepositions are regions of the spatial domain, or they are vectors in the spatial domains. There are 2 different categories here. Verbs, then the manner verbs are vectors in the force domain, result verbs are vectors in the property domain. There can be null vectors in the result case. But this is the mathematical ontology of the space. Now I look very strongly at Bob up in the corner there, because the question is whether we can turn this into a semantic category. I mean, this kind of constructions can be defined in category, in terms of category theory. Yeah, and I mean, I don't know enough about category theory to answer this question myself. But I mean, I've given you some ways of sorting up the different things. I made simplifications in terms of making these assumptions about single domain that will help you to sort these things up. So I hope we could use this kind of mathematical representation to generate a semantic category. But this is a task I can't develop myself, so I'm inviting all of you to help me here. And let me give you some example of how this plays a role in language, and it's a particular linguistic example. Look at this sentence. This is from a paper by Israel Johnson and Brooks. Look at the sentence, the spinach was cooked. It can either mean that it has a particular state, and that is cooked. And that cooked is an adjective, or it can mean that it's passive participle. It describes the process of having been cooked. So that's a result verb in the other interpretation. And you see, it's the same word, it's the same grammatical construction, but there are two. This word can be given either an adjective interpretation or a verb interpretation. What is the similarity? Well, there is a very close similarity. Actually, I should say that children learn the adjectival use first. They understand this kind of use first. And my interpretation of this is that the adjectival marks the end point of a result vector. So that's a point in some kind of property space being cooked, while the passive participle marks the whole result vector. And it's the same vector. I mean, both sentences refer to the same vector. But when you have an adjective, you focus on the end point of the vector. When it's used as a verb, it's the entire vector that is referred to. But the content of the sentence is the same. But we use two different grammatical constructions. Actually, they turn out to be the same. And there is, of course, a very strong correlation between which verbs can be passive participles and which adjectives can turn into these verbs. So, and of course, the reason why children learn adjective first, because adjectives are easier to learn. You have to find one property. It's easier to learn a point than to learn a vector. Stupid answer, but still, that's my answer. And yeah, that's one way of formulating it. Now I'm actually, I don't know, the next talk will be by Bolton and All.
All is here, but Bolt no.
Yeah, Bolton's not here. Okay. Anyway, I read this abstract on the plane coming here, and I'm looking forward to the talk. Here is a bit compressed summary of how you should get a category theoretical analysis of semantics and grammar. And here you say, choose a compositional structure, make it a grammar. I think this is a Lambert calculus generally. And then you do meaning spaces, and then you turn this into a semantic category, and then you interpret, you make a mapping between the grammar and the semantics category. And then you say bingo, and then it maps the reductions of the grammar category onto verbs here. I want to simplify this process. So my recipe would look like the following. Choose or craft appropriate meaning or concept spaces. This is what I've done here, I think. I mean, this is what I wanted to do at least. Then you turn this into a semantics category. And I can't do this myself, so you go to a workshop in Glasgow when you meet people help with this in the following step. And the following step is to use this semantic category to generate the compositional structure. That's why I talked about you have these components, and they will put constraints on what kind of Lambek structure you have. My addition here would be that instead of having only one noun category, you would have several noun categories. Instead of having only one verb category, you would have two verb categories, the force and the result. So you would have a bit richer grammar structure than what Lambek has. But it comes out from, you could generate it from this. And what you gain is that you don't need it. Oh, and of course, this compositional structure can go different ways. You can get different grammars from the same semantic category. You can choose different parts. There are many ways of doing it. So you save one step here. You don't need to make an interpretation of the grammar. Thank you very much.
Are you saying how do you call these, like force and shape? Do you call these domains?
I call them domains, yes.
Do you want your domains to be objects of a category?
Yes.
Okay.
That's why I focused on the domains. They are the things you build the categories out of, yes.
Another question, how do you do quantifiers?
I haven't done. In my book there is one page on quantifiers, and it's totally non-logical. I build on an idea from Lanak, and I don't want to give it here because I have to repeat it then. And I have to rehearse it. I didn't prepare it. So quantifiers I don't really have a good theory for. No. Okay.
So there was quite a lot of information in your talk, so I may not have understood very much.
No, fine.
But throughout the whole thing I was having this picture of some kind of fiber setup, where you have some big space of objects and small space of domains and fiber bondage domains, things like this kind of property.
Yeah.
Is this a sensible way of understanding what
it probably is. I know nothing about fiber theory. But I am working with a German mathematician, Jürgen Jost, who is an expert in fiber theory, and he says he can translate conceptual spaces into fiber theory. I don't know how it's done, but apparently there are some connections. But I know nothing about that theory.
When you talk about nouns, you represent them as a product of domains.
Yeah.
But then my idea is that you can classify a noun by the properties that define a noun. Now this is a very difficult problem, it's like since Antisthenes in the ancient Greece, they try to solve it. They used to say a horse I can see, but horsehood I cannot see. So it's very difficult to, everyone has clear in mind what an apple is, but it's very difficult to state all the properties that localize precise apple. So how do you think you can somehow solve this problem and having a clear representation of an object in mind?
I can't solve it if you hope to have a unique meaning of the word apple, because there are, depending on how much information you have, how many domains you take into account and so on, you get different meanings. So if you're a kid, you're only going to go by a few aspects. If you're a pomologist, that is a fruit expert, you have lots of more information and more meaning of apple. So apple is not doesn't have a unique meaning. It varies. But there are going back to the Greeks, they talked about essential properties. I don't like essentialism in general, but I say that some domains are more important, more central for the meaning here. And I would say for everyday meaning of apple, it's the shape, the color, and the taste that are the more important ones.
I'm not talking about defining properties, but properties that make you able to distinguish an apple from another red round fruit, like a tomato. That's my point.
Yeah.
So how can you specify that? Because you can always find something that is not an apple but really looks like an apple, and people can tell, no, it's not an apple, but it's very difficult in this framework.
Yeah, no, sure. Tomatoes can have the same shapes as apples, so shape doesn't go. Colors can be almost the same. But there are some. Of course, the taste will be the crucial domain here to distinguish.
A very quick point on that. People can't always distinguish. It's a well-known thing in children language learning that children get to about you know,
Thank you.
12 months old see their first sheep and say doggy
Yeah.
if they've grown up with a dog, and they gradually learn, no, it's
No,
not doggy.
that's exactly what's happening, because they don't have enough information about the distinction between different animals. They don't have enough names. There is a very strong shape bias in when children learn new nouns.
So I did want to ask you a question. It's probably an obvious enough objection. You must have thought about it. But the notion that a property has a single domain doesn't cover cross-domain properties. Like size is the obvious one. A large disk drive. You know, we don't know whether we mean the size of the box or the capacity. A long time or a long thing, there's a sort of very deliberate ambiguities there that make it easier to grasp what long means when referring to time.
Yeah, no, I mean we have metaphorical, and actually a large disk drive. I never thought about that, but it's a good example. I mean, you don't mean the size, you mean the content, and you use it in metaphor. I mean, you have this idea of the space of storage, and that's an abstract space, but you can still talk about it in some kind of metaphor. Or take my favorite example, criminal lawyer. There are two interpretations there. I mean, the ordinary meaning of criminal, but then you have the metonymic use of criminal lawyer. I mean, the lawyer that takes on criminal cases. That's you're transferring it to via metonymy to another meaning. So I mean, this is very common. Of course, we have lots of metaphorical, metonymical uses of words, and I didn't talk about metaphor and metonymy very much here, but I could do more about that. Yeah. Thanks.
So perhaps another question on applehood.
Yeah.
Basically, it's three things that you said at different parts of this talk. So you started with the color spindle, which is a convex set,
Yep.
and then you talk about apple,
Yeah.
and you said that well, apples are red, green, yellow. And then at some other point you said that you're thinking of convexity in terms of polar rather than in terms of... So here's perhaps the question. The convex structure that you're putting on the spindle, it's not the Euclidean one, it's
Very
some
good.
sort of polar one.
The polar comes up there as well, yes. You have to define convexity on the color space in terms of polar coordinates as well. Thank you.
In which case, here's the second part of the question. You could say, and perhaps you're very happy with this, and I'm actually quite happy with this. You could say that between red and green, the intermediate point of red and green is not actually a single color, but it's both yellow and blue.
Ooh, yeah, okay.
Because when you have circles, polarity, doing a convexity might give you more points. For example, on a sphere, antipodal points have the entire equator as...
No, okay, I mean, but still, the set of red, green, and yellow of colors is a convex set. And the set of red, green, and blue colors is a convex set.
Yeah.
So that's no problem. Then of course there could be more than one point in between, so they're in the middle of. That's a peculiar case of the polar coordinates, which we wouldn't find in the Euclidean or
Sure. So you'd say that the set of the ring of fully saturated colors is convex with perhaps multiple, like let's say an ambiguous middle point, or you would say that
that's fine. That's fine. I mean, I don't see any problems.
No, neither do I. But
we're just used to think of between us as a unique middle point. If you city block coordinates, you have two things in between as well.
Yeah.
So,
of course,
no problem.
Sure. Thank you.
So at the beginning of the talk, when you introduced the convexity of domains as a very general principle, you mentioned the name Jäger or somebody again. When you said he kind of confirmed that these structures. How can he do that? Because I'm not sure exactly how precisely mathematically you mean the notion of convexity. I mean, you would have to test that all elements that are on a line between these 2 points belong to the...
No, there is a very large data set called the World Color Survey, where you have gone to about 120 languages or whatever, and you present people with Mansell color shifts. These are the color shifts covering more or less not the full color spindle, but the surface of the color spindle. Then you ask people to name these colors, to say what is the word in my language for that. And for some of the languages you only have one informant. He had to kick those out. So if you have languages with only two, I mean, he kept them. So he went down to I think 108 or 10 languages. And there are some statistical aberrations, because if you have two informants, I mean, they almost don't agree well enough. But anyway, he got something like 94% of the data set could be explained in terms of convex regions. And for the big languages with lots of speakers, it was almost perfect fit, where everything was convex. I mean, there are always statistical variations here. So, yeah. So that's how you do it.
Alex, this is going to be our last question.
This goes back to a point pretty early in your talk, in which you noted that the grammatical categories with which we're most familiar, verbs, nouns, adjectives, and so on, are actually characteristic of Indo-European languages. But it struck me that when you described counterexamples for other languages, in every case, unless I missed something, the grammatical categories that you found in those languages were all refinements of the Indo-European one. Do you know of examples in which this is not the case?
The problem is that my language is confined to these categories, so I don't know how to describe the other categories. So, just to give you a famous example, it's claimed that Mandarin has no adjectives. Instead of saying that the table is brown, you say table browns, basically. But then people have said that there are some that are typical adjectives, they still use this, but so the category lines borders don't fit with the Indo-European borders. That's basically
So there is perhaps, just very quickly, possibly this is an answer to your question, in Welsh there are things called verb nouns, where there's one word which can be both a verb and a noun all the time. Don't know if that helps.
Yeah.
You mean regardless of context?
When you put it in context, you know what it is, but when it's on its own, it means both.
But that's true in English too.
Yeah.
Not for all verbs.
Not all
For
verbs,
all
no.
verbs and nouns. Right, sorry, actually, it's not true for all nouns either, but for all verbs it's true. So you can nominalise it.
You can nominalize all.
It's really hard to explain. Sorry.
Let's thank you again.
Thanks.